Okay, this video will show you how to draw some of these molecules. So again, this is the equation that we were looking at before, and we've got a hydrocarbon reacting with oxygen, which is a combustion reaction. When something reacts with oxygen, it's called combustion, and we get CO2 and water. Okay, so hydrocarbons are fuels. When they react with oxygen, we always get CO2 and water. Now, when we balanced it, we got 2, 7, 4, and 6, but we're not going to worry about those numbers now. Okay, we're just going to leave them off because I just want to draw the covalent molecules that we have. So we've got 2 carbon, and carbon always wants to have 4 single bonds around it. Now we've got 6 hydrogens to pair up with my carbons. So the way that this molecule is formed is like this, because carbon has 4 single electrons around it that it wants to pair up with another molecule, and here it pairs up with hydrogen, hydrogen. Here it pairs up with the carbon, here it's with the hydrogens. Okay, so we've got the 6 hydrogens surrounding the 2 carbon. And oxygen, so oxygen has 6 electrons in its outer shell, and when we did these last week, we saw that there's 2 single ones like to join up and form a double bond. Then we have the 2 lone pairs there with the straight lines, which you can include, or you can just not include them if you don't want to. So you can have that diagram for oxygen, or you could have something just like that. Okay, so then we have, we'll just get rid of that one. Then we have carbon dioxide. So carbon dioxide, if you remember when we tried to form this molecule, we saw that this single bond wanted to pair up with that one, and this one wanted to pair up with that one, and the carbon has 2 electrons here, and we know that we have 2 oxygens, so I'm going to draw another oxygen here, and that single electron wants to pair up with that one, and that one will pair up with that one. So 1 bond, 2 bonds, so double bond to that oxygen, 1 bond, 2 bonds, another bond to that oxygen, and we can put those lone pairs in for the oxygens if we want to, or we can leave them off. Okay, so that's my carbon dioxide, and then finally I've got my water, which I'll just include down here. So water, I know I've got 2 hydrogens and 1 oxygen, and so what my water is going to do is the hydrogen is going to pair up with that electron, this one's going to pair up with that one. So it's going to look something like this, with my lone pairs there, which you can draw as single lines, or you can just leave them off. So this would be worth something, this would be worth practicing, girls, how to draw these. So you can either leave those lone pairs there or just leave them off. So I've got my carbon dioxide there and my water. Okay, so maybe we can have a go at doing this one too. So here, C5H12. Now, you might be wondering, oh, well, I don't know if I should include a double bond or not. Like, will it be all single bonds between my carbons? Well, here, see how that's 12? You can kind of straight away tell that the number of hydrogens is double the number of carbons plus 2. And remember, for alkanes, the formula for alkanes was 2n plus 2. So see how 12 is double carbon plus 2. So we know it's an alkane. And what does that tell us? It tells us that there's going to be all single bonds. If it ends with ane, it tells me that there's all single bonds between my carbon atoms. So I can just draw them out like this. 1, 2, 3, 4, 5. And then, because carbon always wants to have 4 bonds around it, I'm going to fill all those others with the hydrogens. And I should have 12 in total, which we can count in a second. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's my molecule of this alkane. Now we probably should try and name this as well. Now 5-carbon, the prefix that we give is pent, and because we know it's an alkane, I end it with ANE, so this is pentane. Reacting with oxygen, and we get CO2 and water, which don't really need to draw them again because they're found here, oxygen. Okay, so just remember you can have them with the lone pairs or not, so that's totally fine. The CO2 is like that, and the water is like that, H2O. So it'd be worth remembering how to draw that, and that. And then the alkanes and alkenes, we're going to be practicing a bit as well.